Hello everyone, today this is the second part of the Cinemachine videos where I will continue explaining the Cinemachine package, exactly the version 3.103, and today we are gonna talk about the last one, the Spline Dolly-Camera. Like in the previous video, I explained all the camera like the clear shot camera, mixing camera, sequencer camera, state driven camera, so we are left with Dolly-Camera and Dolly-Cart with Spline. First of all, we go to the inspector under Cinemachine. We will start by explaining the Dolly-Camera with Spline. So when we click, you will have two components. But before explaining the two components that come with it, you need to understand all the options given under procedural component inside the Cinemachine camera component, that are the position control and rotation control. Like you see, you have only one option in position control, that is Spline Dolly, for the case of the Spline camera. And the Spline Dolly, that means the camera will follow the spline path. But in the other side, the rotation control have 5 options with 2 specific in case of the Spline case. That are the rotate with follow target and Spline Dolly look at target. The first component is the Cinemachine camera set automatically to Spline Dolly, and that come with a Cinemachine Spline Dolly component, and this is what holds the data of how the camera will move in the spline. The first parameter is spline, but don't fall into the trap that is a spline component. So there is it. But in reality, it only accepts spline container. Second is position. And like you see, a drop down that shows 3 choices that are normalized, not, and distance. And you must understand them because they are the foundation. The normalized, it take all the distance of the spline and normalize it between 0 to 1. So the first point is 0 and the second point is 1. The node, it divides the spline by the number of the node. Then the distance between each node is 1. So in this drawing, we have 4 nodes. So between each node is 1. So between 0 and 1, 1. Between 1 and 2, 1. So we have 3. 3 of one value. And the distance, it calculates the distance in the workspace, like in meter, in units, centimeter, minute, or kilometer. Of the component, like you see right now, we have there is knocked, and this count how many nodes inside the spline and calculate the distance between each node. So like you see, there is the spline, and like you see the first node, the second node, and the third node. And if we go to the second object that comes with the camera, that is spline container, we see that hold all the data of the spline. In our case, we have 3 nodes, and you can move it inside the inspector by clicking in this tool. When you click, you will have access to the spline editor. If you click in a node, you will have all the data inside the element inspector. And the element inspector shows the node index with the position, the rotation, and even specific. So in the same tool, you have the spline. There is it. When you click it, there is like you see it. First of all, you can select the number of nodes you want. And when you select every node, you can choose to position it, to rotate it, or to move it, to move the same. But in our case, we choose the Bezier. The Bezier is one of the 3 modes, the linear, the auto, and the Bezier. I choose Bezier because you have the full control over the node position, rotation, like here. You have the full control of the transit. You can move it, rotate it, and all the possibility you have. When in the Bezier, you have 3 types: the continuous, the mirrored, and broken. The broken, you will have the tangent divide, so you can move the first part of the tangent like this, the other one like this. So you will have a broken handle, and with this broken handle, you can control the outbounds of the spline part and the other bounds with the other handle. But the continuous, you will have the handle the same, not broken, but you can change the distance between the two handles. But in the mirrored who choose, you will have the handle like a mirror. So if you scale it out, it will scale out to the other part. If you scale up, so you will have like a mirror, and you have a full control of the curvature. And like you can select each node and give it a specific mode, like here auto, and the other node a linear. And like you see linear, it became linear line with no curvature. But I will make it Bezier, always mirrored. So now you can have a full customizability. Like here, I will make it a circle. Excellent. And now you will ask why it is a circle. How did I connect? If you go to Spline container and you check close it, you will have a circle. If you uncheck, it doesn't become a circle. But I uncheck. And one thing, like here, you will ask me why I can't adjust the smoothness of the curvature, because you have automatically this extension, the Cinemachine Spline Smoother, set to true. You need to turn it off so you can have the control over the spline handle, tangent handle. And if you want to set up the in and out curvature, you can have numerically, you can make it from the element inspector. But right now I explained how you can move the spline and have all the important. And like you see, the camera starts here. If you move, the camera move with it. Excellent. One thing you need to know, I forgot to tell you, is if you want your spline to be visible, you need to toggle the gizmos. This one, the gizmos icon. So you will have the spline visible. And you will ask me why I have an empty parent that hold 4 spline, and I can in the spline container create a multiple of spline, because I will tell you in the future when I will explain the code. But right now I have 4 spline container with just 1 spline with the index of 0. In the code I will explain you. So now let's continue the explanation. Then you have the spline offset. The spline offset, like I said, it will give the camera an offset with the spline path. Like if X and there is it, you will see this small X difference. But it's a very rare that you will need an offset, because the spline, it will be the path. Then you have the camera rotation. The camera rotation, you will have 5 options: the default, the spline no roll, the follow target, and the follow target no roll. The default is this one. Then we have the camera rotation. The default one, it gives you the capability of choosing the rotation of your camera, and this rotation will be fixed when the camera move through the spline. Then you have the spline. Automatically it will be, if I like you see, the forward axis of the camera, it will be the same as the tangent of the spline. So if we move, I will zoom out to see. One thing is I need to make it a little bit up. Excellent. Now if you see the camera, it will be like the tangent of the spline. It will follow the forward direction of the spline, and in here you will see a little bit of rotation around the forward axis. This is the spline. The spline no roll, the same as the previous one, but no rotation around the. So here you will see there is no rotation around the forward axis. This is the option spline no roll. And here, don't be fooled. The follow target, it will not follow the target I mentioned, but it will follow the world up axis of the tracking object that is mentioned in the Cinemachine brain. Like here, the world up Cinemachine brain 2 is the side of the ninja. I will zoom it. The y-axis of it is the same as the y-axis of the camera. If, an example, let's go here, the spline, there is the camera view. Now, if I change the rotation or the rotation of the tracked object, the camera will follow it like here. But before we click in the drop down, we go to the Spline-Cart camera. So now, if you rotate, you will see it will rotate with it, because they have the same y-axis. And this is important when you have a top-down shooter, when you need to specify the up axis. Like here, we need a rotation of 90, and voila. And the last option is like the previous one, but with no roll, like the spline no roll. So the object, it will not rotate in the forward axis. So if I choose it, and you came here, and we made a rotation around the forward axis, that is the Z axis, I think it will work in real time. So let's press play, and we will see. So the camera must not rotate around the forward axis like this. It will not rotate. Excellent. So the camera is fixed. Excellent. So then we have the automatic dolly. The automatic dolly, when you check it, you will have three methods: the non, the nearest point to target, and fixed speed. Non, it will not affect it, but it will give us an automatic movement. The fixed speed, you will give it a speed. So this is the speed that will camera move around. This Z-series movement is just because it conflicts with the script I gave it to the camera. If I turn off the script, there is it. It's too much. We reduce it to 0.4, I think. Good. There is it. I know why. Because 0.4 because it's normalized, and 0.4 it's like the half of speed. I think I need to 0 to 9. This will be slow. Excellent. And like you see, an automatic movement dolly with a fixed speed, and you give the speed. And here, the nearest point to target, I will tell you, the target is this one. Target is the tracking target that is in the Cinemachine camera of the spline dolly. That is the world up, is the side of the ninja game object. So now, the camera move according to the position of the tracking target to the nearest point. So if we take the object and we move it outside the spline, what is the nearest point of the spline to the object? Is this one, and there is it. And you ask me why it's not here, and he is here, because the source resolution and iteration is very small. If we take it very far, and now we move the object like here, the search, it will be very efficient, but it will be a time consuming and a performance hurdle on the CPU. So this is why you leave the default value 4 and 2. I think you don't understand because. So I will reset it, give it a 90. So now I will move the ninja, because it's the parent. And one thing, there is it. So now, if we move the ninja, the camera will stay very close to it, the nearest point of the spline to the target object. There is it. And like a teleportation. And voila. The nearest point. And it can teleport from this part to the other part just for to stay close to the object. So I think I explained it. I will check out. So, and the dapping is a self-explanatory. It's the responsiveness of the camera following the object in different axes with an and different angular speed. No need for the damping. So the Cinemachine Spline Dolly component is explained. Now we finish it explaining this component. We'll go to the rotation control. Like you see, if we choose rotate with follow target, we will got this simple component with a one variable, the damping. So it's not difficult to explain. It's the easiest component. But the important component is this one, the Spline Dolly lock at target. Like you see, you have this component with an index unit that lists the three options and the data points. First of all, in the docs, they encourage me to use the note, because the note, it will preserve the data point with the distance, and if you check the spline and change his width, distance, height on the width, the index unit note will keep tracking of the object. And if you read the name, you will note that this spline will look at a lot of targets. So this data point, it will hold the target info with the index, the lookout, the offset, and the easing. The index, it means it's the same index of the node. So that means if in the index of 0.5, first of all, we go to the spline, always the node, excellent. So, per example, we zoom out to see there is it to the spline. So, in the index of 0.5, that means here, like here, we want to look at the giant. So we will drag the giant. And voila. So in the index of 0.5, so that means the middle distance between the two first nodes, we'll look at the giant, and we have the offset and the easing. No need to touch them. We will add another target. This one, 1.5, and 1.5 is here. So always keep an eye on the scene. There is the 1.5. This time we will not see the giant, we will see this cube. Wait, where is this cube? There is the cube 5. So we will drag the cube 5. And voila. And we will add another. Let's make it 2.5. Always remember this as same the index of the knot here. We will see the player. So now we will reset the position 0 and place play. And voila, we see the giant in the half index. In the 1.5 we will see. And here we will see the giant. The other spline the same. And voila. Just one thing before finishing the explanation of the spline Dolly lookout target is you have in the scene view. If you click on this tool, you will see the target, blue gizmos that point to the target, and at the index and with the lookout. And with it, you can specify a complex scene with a complex object. So you can have a fully customizable lookout target. So in here, we ended the Dolly camera with spline. We disable the ball, then we go to the spline cart object. Like you see, this the Dolly spline cart is the spline that we will use it with the Dolly-Cart object. And like you see, the Dolly-Cart doesn't have a name. Like here, the Dolly-Cart doesn't have a name. Why? Because the Dolly-Cart, it take a game object and force it to follow the path of the spline that come with it. So it's like a road, and you can even use animation, so you can resist the animation of an object around the path. Like here, the red cube is a red box, and if you see, if we move it, it follow the spline. And like you see, the Cinemachine spline cart is an extension. It's an extension that, like always, it holds a spline container, the position, explain the update method. You will choose which loop to follow the update of movement. Then you have an automatic dolly with a method and the speed. Like always, I already explained it, but here another extension, the Cinemachine spline roll. We will turn it off. Then, like you see, the object, it follow the path and rotate according to the spline. But if we add the spline, Cinemachine spline roll, the object starts rotate. Why? Because this one is like the Cinemachine look at targets. When you specify the index unit, you have a data point in each index. You can give the object that hold the component a specific role. Like here, 50, minus 50, minus 50, and 180. And with it, you can give a beautiful rotation movement of objects. And this camera is very helpful if you have a boss room when you need to show to the player the different enemy, or a puzzle room when you need to show the player different objects. So with here, I explained the two components. I hope you are okay, but I will add a bonus, a sample script that you can use it, so you can move your camera, and with this script you will know how to use the code to interact with the API of the Cinemachine. So you can implement a complex mechanism with code for your Cinemachine camera system. And there is a script. In the first line, we import the namespace of the Cinemachine and spline. Then, like always, we declare the variables. The first variable is the Cinemachine camera variable that will hold all the component Cinemachine camera. And you must know that the new API we use the Cinemachine camera. In the old API, they were using the virtual Cinemachine camera. Then, because we are working with the spline dolly camera with spline, we need to access the Cinemachine spline dolly component, so we can have access to all the options. Then you will see we have a private spline container that holds the information about the spline, the path of our object. Here, a sample bools and the float for the movement of the object. The majority of the float is the time value. Then we have a private transform. The spline parent is the empty parent object that I told you about in the beginning of the video. In the start, inside the spline dolly, we get the component that is extracted from the spline camera. Then when we have the component, we will access the position unit method, and we will set it to normalize it. Then the spline dolly camera position always in the start must be 0. It's like resetting the position. Then in the spline contain, it will hold the component spline container from the spline contain. Here a sample if the bool is true, we start moving. And the list all spline is just a method I developed to see all the spline in the scene. It's just it loop a for loop. It loop in the count of the spline in the spline content. Then it will create a local spline data object that will hold the spline of the container with according to the index. We will return, start moving. The start moving is simple. Set the current time to 0, is moving to true, to make the if statement to true. The current time is incremented by time.delta time, and because we are in the normalized, we use the matf clamp 01 and we divide with duration, the current time with the duration. So we can have a normalized value. And this normalized value, we will pass it to the camera position of the spline dolly component. And then if the value of the camera position, that means in the inspector, the position is bigger or equal to 1, and we check and again if we have a loop to repeat, or we stop moving, and in the stop moving we set the bool to false and we fire this void, the switch to spline, and with a parameter int with name spline index. First of all, we check if we have a spline container and spline only component, always the two important components. Then if the spline index is inferior to 0 or the spline index is bigger or equal to the spline parent.seed count, that means we are out the range and we don't have spline. Else, we take the child of the parent object spline parent, and with the method get child, we can have the value of the index. Then the spline container, a local spline container with the name select component, will get the spline container of the specific child, that is the child of the parent with the corresponding index. Like you know, the first child is index 0, the second child is index 1, and so on, so on. And always we check if it's null, we return. Then the spline dolly, we got the method spline setting, we take the spline, and this method it accepts only the spline container. I already tried a lot of methods, so we can change the spline corresponding in one spline container, but I don't find in any place a method so we can have access to specific index of a spline inside of spline container. So the best method is to have spline container, multiple spline container, and we affect them each time a specific spline container with his response corresponding spline. Then we switch dolly to spline as index, spline index, then a sample debug log. So there is a sample script where just by accessing the important component with code, you can have a list of all the methods and you can develop your own complex logic. So I am happy if you stay until this moment in the video. Subscribe, comment, like, and let's meet in the next video.